What's up? I'm Vin, and today I want to go through the 2021 Grade 8 PSSA math samplers, so let's get started. So for the first question here, we're talking about Jupiter, which is 10 to the 14 cubic kilometers in volume, and then we have Earth, which is 10 to the 11 cubic kilometers. We want to know how many planets the size of Earth does it take to equal the volume of Jupiter. So for this one, the thought process that I go with is I think of something simple, and then I translate it to this question here. So I compare my weight. At one point, I weighed 200 pounds. And one of my little kids weighed 20 pounds. Okay, so yeah, one of my sons at one point weighed 20 pounds. So how much more or how many times bigger than my little son was I? Well, if I do my weight, 200 divided by 20, that would be 10. And that tells me that I weighed 10 times more than my son. Okay, so yeah, I'm just much bigger, but eventually they'll catch up to me. So if we translate this over here, Jupiter is the big planet. That's 10 to the 14. And we're going to divide it by the little planet, which is 10 to the 11. And if we do the division here, we're going to use law of exponents. We're going to have 10 to the 14 minus 11. And this would work out to 10 to the third power. So this tells us here that it would take 10 to the third power, if we wanted to know what's going on here, is 1,000. So that means that Jupiter is 1,000 times the size of Earth. But we're just looking for the correct answer choice here, which is going to be choice B. So for the next question here, we have the Blue Ridge Mountains are rising at a rate of 1 times 10 to the negative 4 feet per year. And to determine how many feet the mountains will rise over this many years, a scientist performs the operation shown below. And we want to know how many feet will the Blue Ridge Mountains rise over the next 1 times 10 to the 6 years. So for this one here, we just have to complete the operation that the scientist set up for us. But what we want to do here is use commutativity of multiplication. So notice here that we have 1 times 10 to the negative 4. We have 1 times 10 to the 6, and we're multiplying those two. So what I would rather do here is group 1 times 1. So I'm just going to group these two terms together. And then I'm going to multiply that by, I would do 10 to the 6 times 10 to the negative 4 power. I could also write 10 to the negative 4 times 10 to the 6, but once again, with multiplication, order does not matter. So here we have 1 times 1 is 1, and now we have times 10 to the power. We use the law of exponents, and we're going to add. We're going to have 6 plus negative 4. And if we add those two, 6 plus negative 4 is 2. So this would be 1 times 10 to the second power. And then if we just did 10 times 10, that's 100. So 1 times 100 equals 100. So how many feet will the Blue Ridge Mountains rise? It's going to be 100 feet. So question 3, we have Trevor's riding his bike for a workout, and the graph shows the relationship between the amount of time in minutes he rides and the distance in kilometers he rides during his 25-minute workout. Based on the graph, which statement about the rate at which Trevor rides during his workout is true? So just know with line segments, the rate is the slope. So the slope tells us the rate of change of the line, and the rate of change or slope of a line is something we could find using this formula here, y2 minus y1 over x2 minus x1, where x1, y1 is 1 point and x2, y2 is another point. So let's say I look at these 2 points here, 0, 0, and this point here, 15, 2. So I'm just writing the x, y. So if I find the slope between these 2 points, that would tell us how fast Trevor's riding for the first part of his workout. So here, if we do the difference in the y values, I'm going to have 2 minus 0, and the units for the y values are kilometers. So I'm going to write that next to it. So we have 2 minus 0 kilometers divided by 15 minus 0, and the units for the x are minutes. So now if we simplify this, this would be, we would have 2 kilometers divided by 15 minutes. But now think about this. If we look at the answer choices here, this would tell us that Trevor rides 2 kilometers in 15 minutes. But none of the answer choices here have that specific combination. There's no 2 kilometers for 15 minutes showing up here. So what I would do from here is I would take this rate, the 2 kilometers per 15 minutes, and I would divide the top and bottom by 2. And what this tells us is that Trevor goes 1 kilometer every 15 divided by 2 is 7.5. And we just tack on the minutes here. So now I scan the answer choice, and there's only one answer choice that has 1 kilometer for every 7.5 minutes, and that's choice D. If I really wanted to be safe here, what I could do is I could write this point out. So this is the point 25, 6. And if I find the rate of change between these 2 points, notice I would have 6 minus 2 divided by 25 minus 15. And this would work out to 4 over 10. And now I could write the units, kilometers per minute. And then notice here that if I were to divide the top and bottom by 4, if I did, and I'll write that over here off to the side, 4 divided by 4 is 1. So I have 1 kilometer divided by 10 divided by 4. So I'm just doing divide top and bottom by 4. 10 divided by 4 is 2.5. So now if I look at choice D again, notice his rate changes to 1 kilometer every 2.5 minutes, which matches the slope of the second line. So choice D is definitely our answer. So question 4, we have Davis's cars, and we're talking about the gas mileage here. And for his old car, he gets 19 gallons of gas to go 323 miles. And for the new car here, we have a graph for the gas mileage. We want to know what is the difference in the gas mileage for the two cars, and the units here are miles per gallon. So to find the miles per gallon on the old car, all we have to do here is do 323 miles divided by 19 gallons. So I'm doing miles first because we want miles per gallon. So I'm going to put the miles up top. So that's what we have over here. So to find the actual rate, what I'm going to do is I'm going to divide 323 by 19. So this we could just do in a calculator, or you could do the division like this. You could say 19 goes into 32 once, and that would be a remainder of 13. And then 19 goes into 133 7 times like this. So this tells us the old car got 17 miles per gallon. And I'll just abbreviate like this. So 17 miles per gallon, but we have to be careful here. We're looking for the difference. So if we just jump right away to choice C here, this would be a very dangerous bear trap. So we move on here and say, well, what's the miles per gallon of the new car? And for this one here, we just pick out a random point on this line, because just know that the slope of a line never changes. So the slope of a line does not change. So let's say I pick this point over here. This would be the point in between 50 and 100, that's 75. So this would be the point 75, 2. But this tells us that Davis gets 75 miles for every 2 gallons. So I'm just going to write the point here. Notice this is the point 75, 2. But the 75 is miles, and the y-axis 2 represents gallons. So now this I could just divide. 75 divided by 2 is going to be 37.5. So I'm just doing 75 divided by 2. So this is 37.5 miles per gallon. So now we want to know what's the difference between the gas mileage. So we're just going to do 37.5 minus 17.0. And this, once again, we could just use a calculator or just do the subtraction ourselves. So we get 5 minus 0, 7 minus 7, and then 3 minus 1. So 20.5, choice D is our solution. So question 5, we're talking about two lines here, and this formula is going to be very helpful. We have y equals mx plus b, where m represents the slope, and that tells us the direction of the line, and b represents the y-intercept, which tells us where the line crosses the y-axis. So we have line J, and I'm just going to label that over here. We have line J has a slope of negative 2/3. So that's our m value, is negative 2/3. And the y-intercept here, it intersects the y-axis at negative 4. So that's the b value, is negative 4. So I would just write the equation of the line here. We have y equals negative 2/3 x, and then we have minus 4 like this. So now we're going to shift over and talk about line K. So that's the next thing we care about. Well, what we know about K is that it has a different negative slope than line J. Well, notice here that the slope of line J, once again, is negative 2/3. So we need the slope of line K to be something negative, but not negative 2/3. Well, notice here, choice D is automatically out because the slope of this line is 1. There's an invisible 1 in front here. So this is a positive slope, not a negative slope. And then choice B is also out because the slope of line B, or the slope of the line for choice B, is also negative 2/3. So this one is also gone. So now we move to the final condition here, that line K has a y-intercept here that is above line J. So if you think about a little visual here, this is what I'm thinking of, is what does this line look like, line J? So this doesn't have to be exact, but what I'm imagining here is that for line J, the y-intercept is down here at negative 4, and the line has a negative slope, which means the line is going to be decreasing like this. So whatever line K does look like, we want the y-intercept to go above this y-intercept. So this is line J. We need K to go above this. So C is out because if the y-intercept was negative 5 and it had a negative slope here, this line would be temporarily would be under line J like this. So at the y-axis here, it would be under. So that's why choice A has to be the solution here, because negative 1/6 x, this would be a line that's decreasing, and the y-intercept, once again, is above the y-intercept for line J. So choice A is definitely our solution. So question 6, we have Louisa is solving an equation at the bottom of a page, and the corner where the equation was written was torn off, and Louisa knows only one number was torn off, and the equation has infinite solutions. So what must be the missing number? Well, just know that when you have infinite solutions, what this means is that both sides of the equation match. So both sides of the equation match. And what I'm imagining here for something like this, before I jump into this, is I think of something much simpler. Like let's say I had 2x minus 4 is equal to 2 times x minus 2 like this. If I distribute the 2, I'm going to have 2x minus 4 on the right, and I still have 2x minus 4 on the left. And no matter what x value I plug in, both sides are going to match. So this has infinite solutions. So that's what I'm imagining. So what I have here is I'm going to distribute the 7 on the left, and I'll have 7x plus 21 equals, and then if I distribute the 7 on the right, I have 7x plus 7 times 5 is 35, but I also have this minus whatever the missing number is, and I could call the missing number anything. Let's say I just call it w for now, and I have minus w at the end. So now what I would do is I would just start solving for the missing term here. I'm going to go minus 7x on both sides, and then if we do that first, minus 7x on both sides, now all the x's are gone, and I'm going to have 21 equals, we have 35 minus w. Now at this point, you might just be able to do this math in your head and see that, oh, 35 minus 14 works. Or if you want to solve this algebraically, just subtract 35 on both sides. And what you'll have is you'll have 21 minus 35, I'll write that over here, is negative 14, and that equals negative w. And then algebraically, what you could do is just multiply both sides of this equation by negative 1, and that would tell you that 14 is equal to w. So choice B is our solution. So when you want to solve a system of equations graphically, all you have to do is identify the point of intersection. So notice that these two lines here cross at this location over here, and the coordinates here, this would be at the point 3, negative 3. So our solution to this system of equations is going to be choice C, 3, negative 3. So question 8, we want to know which relation is the linear function with the greatest slope. So for this one here, we have to know how to write slope in many different ways. Well, one way to identify slope is when you have the equation y equals mx plus b, the slope is simply the number in front of x. The other way you would find slope is you would take the difference of the y values and divide by the difference of the x values. And the slope of a line does not change. So the first one that jumps out at me right away is choice D, that the slope of this line is 5. And I just want to find that slope first because it's the easiest. It's simply the number in front of x. Now, if we were to look at choice C over here, right away, I'm thinking of, well, one more thing is my friend slope guy. And if we look at slope guy, this helps us identify a few features of a line. And what I know right away is anytime I have a horizontal line, like look at slope guy's mouth, the slope of the line is 0. So my slope here would be 0. If I have a positive sloping line, the line is increasing. If I have a negative sloping line, the line decreases. And if I have a vertical line, that's an undefined slope. So right away, without doing any work, I know that this line is going to have a 0 slope. If I wanted to, I could just pick 2 points out on the line, like let's say the point 0, 3. And I look at this point over here, let's say the point, I have 6, 3. And if I found the slope between those 2 points, I would also get 0. So right away, which one is the greatest? I know C is out because 5 is greater than 0. So now we look at this point over here, and what we're going to do is we're going to find the slope between any two of these points here, because notice the y's are increasing by 2 and the x's are increasing by 3. So let's say I find the slope between these 2 points. So think of this as our x1, y1, and then this would be our x2, y2. So now I'm just going to use the formula. The slope here, I would have 5 minus 3. That's the difference of the y values divided by the difference of the x values. So 5 minus 3 is 2, and I'm dividing by 3. So 2/3 is definitely not more than 5, so this one is out. Now, just looking at this here, if I were to plot these points, not necessarily drawn to scale, but I'm over here at 4, and notice I have 4, 0, then I have 4, 10, 20, and 30, that these points form a vertical line. And now think back to our friend here, slope guy. I could find the slope between any two of these points, but if I find the slope between any two of these points, like let's say I did 10 minus 0 divided by 4 minus 4, so I'm using these 2 points. Notice that I'm dividing by 0, and division by 0 would be something that's undefined. So that's why I would have a vertical slope like this. So this one doesn't even get thrown in the mix because if I have an undefined slope, I can't count that as my greatest slope. So out of all the answer choices where we had something that was an actual real number, choice D gave us the biggest number, a slope of 5. So question 9, we have a parking lot is charging a monthly fee plus a charge per day to park cars in a lot. And the graph shows the relationship between Y, the total cost in dollars, and the number of days X the car is parked in the lot. So we want to know which equation could represent the relationship between the total cost Y in dollars and the number of days X the car is parked in the lot. So for this, right away what I notice is that the graph is the graph of a line. So I'm already thinking Y equals mx plus b. So choice B does jump out at me right away. But let's talk about why the other answers are no good. Well, choice C and D are out because x squared and x squared plus b would be in the shape of a parabola like this, which wouldn't match the line. So that's why those are automatically out. But why? But now let's think about why is choice A no good? Well, choice A, if it's just y equals mx and the plus b at the end is technically plus 0, this would just be a line coming through the origin like this. I could draw the line all the way through, but this graph here is only happening in quadrant 1. So that's why I'm starting this at 0, 0. But notice that this graph here has a y-intercept of 40. So it has a b value of 40. So just looking at the answer choice here, that choice B is our best option because we have y equals mx plus b, where b here would represent the non-zero fixed amount that the parking lot charges per month. So question 10, which situation could be modeled by the equation y equals mx plus b? And right away what jumps out at me is that this is a linear equation. This is linear, which tells us that we have a constant rate of change. So a constant rate of change like this. And looking at choice A, I could already see this is no good because if we have the number of butterflies is doubling every month, what I'm imagining is that we have 2 butterflies, then we have 4, then we have 8, then we have 16. But notice that the rate of change here is not constant, that this is going up by 2, then it's going up by 4, then it's going up by 8. So this one is automatically out. Now, choice B is a tricky one, but this one can be eliminated as well because it says the time y it takes a car to travel 100 miles depends on the speed of the car x. And for equations like this, just know distance equals rate times time. But the rate is usually the part here that we're treating as something that's constant. Like if we have a situation where someone is driving, let's say their rate is 60 miles per hour. And I say something like, let's say Hank is driving 60 miles per hour and he's driving at a constant speed and he drives this fast for 2 hours. So for t equals 2 hours, then what's his distance traveled? So the distance would be 60 miles per hour. And then we would multiply by 2 hours. And this would tell us that Hank drove, after the units cancel, we'd have 60 times 2 is 120, and the units would be miles like this. But the problem is that they're saying that the time is y, but this, think about it like this, is the form y equals mx. So y would be the distance. So the distance should be y, and then t would correspond to x. So you see how everything is out of place here. Speed should be the slope or the constant rate of change. So that's why this can't be modeled with this equation here. So I'm just chopping this one out. Now the volume of a cylindrical tank, right away I could see that volume of a tank, a cylindrical tank, would be pi r squared times h. So this is the volume of a cylinder. And notice the r squared right away is going to ruin this here. So this is not going to work out. So I'm just going to chop out choice C. And now if we look at choice D, this has to be it. But let's think about this. The total income Y of a worker who earns $8 per hour. So this is the slope. So we have Y equals 8 times X is the number of hours worked. So the total income of a worker who earns $8 per hour depends on the number of hours worked. This is our solution here because notice Y equals 8X is something in the form of Y equals mx plus b. So choice D is our answer. So question 11, we have Ben currently has $70 in his trip fund and he makes $45 per week doing yard work and he keeps 18 of the $45 for weekly expenses. So this is a really important piece of information. And then the remaining amount goes into his trip fund. Which function can be used to determine the amount of money in dollars that Ben has in his trip fund at the end of X weeks? So for this one here, we have to be mindful that the rate of change here is going to be the $45 per week. But if we're not careful, we might miss this step here that he keeps 18 of the $45 for weekly expenses. So Ben's slope here, we're thinking of the equation again, y equals mx plus b. But our m value here to write this equation is not going to be 45. It's going to be 45 minus the $18 because once again, $18 is going towards weekly expenses. So we would have 45 minus 18. I'll just do the subtraction over here. So I'd borrow and I have 15 minus 8 is 7 and then 3 minus 1 is 2. So the slope of our line is actually going to be 27. And now just looking at this, the coefficient of x has to be 27. Tells us right away that this is going to be choice A. But if I really wanted to play this safe here, I could just think about Ben currently has $70 in his trip fund. And just know that for word problems, the B value is the fixed amount or the starting amount. So just know once again that the slope is the rate of change. So slope, just think rate of change. But in word problems, the b value is the fixed amount or the starting amount. So it's the fixed amount or the starting amount. And since Ben just has that money lying around, that's going to be the starting amount here. So that would be our b value is 70. So now we just write the equation of the line. It would be, we would have 27x plus 70, but then commutativity of addition tells us choice A is correct. So question 12, we have Zach is studying the school furnace's oil usage, and he records the amount of oil remaining in the tank at 8 a.m. every day for a week. No additional oil is added to the tank, and here's a graph that shows the data. And as the outdoor temperature gets colder, more oil is used to keep the indoor temperature constant. So based on this graph, which 24-hour time interval indicates the coldest period for the week? So just looking at this, what we're looking for is when is the slope the steepest? Because think about it, as it gets colder, they're going to burn more oil, which means the amount of oil is going to drop at a faster rate from one day to the next. So just imagine you're sitting on this and this is a slide. So I don't know, this is you sitting on this and you're getting ready to slide down. So when would you be sliding the fastest? And right away, my attention is drawn to this interval here, that if I was sliding down this, I would be a little bit afraid here. If I was sliding down this, I'd be going really, really, really fast compared to over here, and the other days of the week. So when are we going to be sliding the fastest? Between Tuesday and Wednesday. So that's when the school uses the most oil, is between Tuesday and Wednesday, because the largest quantity of oil is being consumed over a 24-hour period. Question 13, we have a triangular sign was moved, and the new location of the sign is represented by the shaded triangle. Which transformations could have been used to move this sign to the new location? So for this one here, if we look at the answer choices A and B, the first thing that's happening is that the triangle is being reflected over the line segment BC. So I just placed this triangle over here. You could see that triangle ABC. If we were to flip it over BC, that would send us here. And then let's think about this, choice A or B. If we reflect next over AC, that would flip us over here to the left. However, if we translate from here 4 units to the right, let's count. We go 1, 2, 3, 4 like this. Notice that this is going to overlap the triangles perfectly. So once again, I'm here and I'm going 1, 2, 3, 4, that this would send me perfectly. So choice B right away is looking good. But now let's think about, why are the other answer choices no good? Well, if I translate 4 units to the right and 4 units down, the problem is if I go over 4, down 4, that this triangle, if all I do is translate it over and down, translating doesn't flip the direction of a triangle. So no matter how much I move this to the right and down, if all I do is translate, this triangle is going to be facing the same way, whereas this one is flipped. So that's how I know that I needed some sort of reflection going on. If I rotate it 180 degrees clockwise about point C, that's going to flip it upside down. But the problem is that flipping it upside down about point C like this and then going 1, 2, 3, 4, this is not going to be facing the direction it needs to overlap that shaded triangle. So that's how I know that these two choices here are out. Choice B is definitely our solution. So question 9, we have the diagonal of Andre's rectangular TV is 39 inches. So the first thing I would do is just draw out a rectangular TV. So there's the TV and the diagonal is 39 inches. So there it is. And the TV is rectangular, so that means that these are right angles over here. And we're told that the width of his TV screen is 34 inches. So we could label this as 34 inches. And now the height of the TV is what we're looking for. Which measurement is closest to this? So let's just call this X for now. And the formula to know is Pythagorean Theorem, that when you have a right triangle, and I'll label the sides here ABC, you have to know the Pythagorean Theorem. That's a squared plus b squared is equal to c squared. And just know that c represents the hypotenuse. And when you want to identify the hypotenuse, it's the side across from the right angle. So right away, I could see here that our hypotenuse is going to be 39. So we have 39 inches, but I'll leave the units out because all the answer choices have the correct units at the end. And then here I could label our A value as 34 and our B value is the missing one. Let's just call that X. So now I'm just going to plug into the formula. We're going to have 34 squared plus X squared is equal to 39 squared. And now we could type some of this in the calculator. Just do 34 times 34. That's 1156 plus X squared equals, and we have 39 times 39 is going to be 1521. So 1,521. And now subtract. So we're going to subtract 1,156 on both sides. And this, once again, we could just do in the calculator. This is going to give us x squared equals, and this will work out to 365. So now we would take the square root of both sides to solve for x. And this would tell us that x equals, and if we write this out to a few decimal places, the square root, I'm going to press second x squared here to pull up the square root. I'm taking the square root of 365, and this is going to give us this value here. So I'll write out a few decimals here. We have 19 point, we have 10497, and this goes on and on. But all the answer choices are rounded to the nearest tenth. So I look here at the tenths place is a 1, and to the right is a 0. So this I would just round to 19.1. And this is going to match choice B. So question 15, we have a grid shown below of rectangle ABCD, which represents the location of a pool at a city park. And we have Anna is swimming in a straight line from corner A, so that's over here, to corner C in the swimming pool. What is the distance that Anna goes in meters? So for this one here, just know each square represents 1 meter like this. So these are square meters like this. Each side is 1 meter long. So what we need to find here is the length of this diagonal. So this is just like the last question here. So we're just going to find the length of this diagonal here. Not the greatest artist in the world, but let's just pretend I drew this nicely. So what I need to count is the distance across and the distance up. So what we have is this is a distance of, we're going to count, we're going 1, 2, 3, 4. So this is a horizontal distance of 4, and a vertical distance, if I go this way, I'm counting up, I'm going 1, 2, 3, 4, 5, 6, 7. So we have a right triangle, and once again, we're going to use a squared plus b squared is equal to c squared. And this time we don't know the hypotenuse, and I'll just call that, well, c is taken. So that's kind of annoying here. So I'm just going to use x. Actually, x is also taken. So this is really frustrating. All right, so how about I just use the letter w like this? So if I plug into the formula, I'm going to have 4 squared plus 7 squared is equal to w squared, because now I'm solving for the hypotenuse. So I would have 16 plus 49 is equal to w squared. So on the side, I'll just add this up, even though I think it's obvious here it's going to be 65, but let's just go ahead and do it anyway. So this is 15, carry the 1, and we get 65. So 65 equals w squared, and w is going to represent this distance. So now I'm just going to take the square root of both sides. So w equals the square root of 65. Choice C is our answer. Question 16, we have a cone-shaped dispenser is filled with cake frosting. How delicious. So the cone has a radius of 1.5 inches and a height of 5 inches. So I'm just going to write that down. R equals 1.5 inches, and the height is equal to 5 inches. And we want to know which measurement is closest to the volume of the cake frosting that is in the cone-shaped dispenser. So here, just know the volume of a cone is 1/3 pi times r squared times h. So here I'll just plug into this formula. This is 1/3 times pi times r is 1.5, and it's being squared, and then we're multiplying by h, which is 5. And then the units at the end are going to be cubic inches, which I could write like this, inches to the 3rd power. So now I'm just going to punch this in the calculator. So something like this we could just type in, and I'm going to have 1/3. So 1/3 I could just write in parentheses like this. So I have 1/3. And then next I'm going to tack on pi, which is second, and I press this up arrow here. If I didn't have a pi button on the calculator, I would actually just type in some values like 3.14159 is as far as you would need to go, because just note here that pi does go on forever and ever, but 3.14159 would do the trick and give you something accurate. Okay, but let's say you do have a pi button, then you're going to do 1/3, and I'm going to multiply that by pi. And then I'm multiplying by r squared. R was equal to 1.5. So I have 1.5. I close this, and it's going to be squared. And then I'm going to multiply that by 5. And just know that parentheses mean multiply. So you could just type it in just like this. You press enter, and notice that we get 11.78 if we round to the nearest hundredth. And that's matching choice B. So once again, we had the volume equals 11.78 cubic inches. Choice B is our solution. So for this last question here, question 17, we want to first find just the irrational numbers. We're going to round them to the nearest tenth, and then we're going to graph them on the number line. So the first thing we have to be able to determine is which of these numbers is irrational. Now, I know the first number here, square root of 12, is irrational because 12 is not a perfect square. And when you take the square root of a non-perfect square, that's irrational. This number here at k would be rational because it's a fraction where the top and bottom are integers, And notice the denominator is not 0, so that's an important condition. But when you have a fraction with two integers where the bottom is not 0, it's automatically rational. So this number we would not be graphing. And the square root of 16 is 4, and this is a whole number, so at point L here, square root of 16 is rational. And then point M here would be irrational because we have 3 over 2 times pi, and pi is an irrational number. So now we could just type these in. We have the square root of 12. So I'm going to press second x squared and I type in my 12 and I press enter. And then for my next number here, I have 3 pi over 2. So I have 3 times pi is at this button here, second, and I press that up arrow. And then I'm dividing by 2. And this gives me my value for 3 pi over 2, but we're rounding to the nearest tenth. So the first number I would round to 3.5, and the second number I would round to 4.7. So now let's record what we have. The square root of 12, once again, we said was roughly 3.5. And then 3 pi over 2, we rounded to 4.7. So now we just have to plot these on the number line and then label them with the appropriate letters. So 3.5 is right in the middle of 3 and 4. So that would be over here, and this is going to be point J. So point J is over here, and then 4.7. Notice there are 10 notches to get from 4 to 5. So this is 4.5, this would be 4.6, 4.7, and that's going to be the location here of point M. So here are our 2 points plotted. So for the rest of question 17, we have an integer is represented by x, we have a rational number is represented by square root x, and the value of square root x is between these two numbers. We have to explain why there's only 2 possible values of x, and as part of the explanation, state the 2 possible values of x. So the first thing that jumps out at me here is that if we take the square root of x, and this is rational, so the square root of x is rational, and we're told that x is an integer, this tells us that x is a perfect square. So x has to be a perfect square, because remember what I said before in the previous part of the question, if you take the square root of a non-perfect square, that would be irrational. So the fact that square root of x is rational is a sneaky way of telling us that x is a perfect square, considering that x is an integer. So now we just have to transfer that over here. So now the next thing to consider is that square root x is between these two numbers here, so we should find decimal values for these two numbers. So for this part, I would just type those into the calculator. We have 84 divided by 18. And then the next thing we're going to have here is we're going to have the square root of 41. So we have the square root of 41, and that's going to work out like this. So now we can just transfer this to the question. So now let's transfer those decimals. We have 84 over 18, and this we could just say is equal to 4.6 repeating like this. And then we had the square root of 41. This we could just round to a few decimal places here. So this was 6.403. So this I could even just round to 6.4 for now, because now when we analyze the rest of this, we're told the square root of x is between these two numbers. Well, think about what we said over here. The square root of x is rational and x is a perfect square. So one other thing we could mention here is that square root of x is going to be a whole number. So the only whole numbers between this number and this number are going to be 5 and 6. So now we could write our conclusion. As part of the explanation, state the 2 possible values of x. So if the square root of x, the possible values are 5 and 6, this tells us the 2 possible values for x would be 25 and 36, because just think about this here. If the possible values for square root x are 5 and 6, just think about this. The square root of 25 is equal to 5, and the square root of 36 is equal to 6. So we could just square both of those numbers, and that would tell us the possible values for x.